Berdoa dimulai.
Yeah, may I start?
Berdoa selesai. Assalamualaikum warahmatullahi wabarakatuh. Selanjutnya kami perkenalkan di sebelah saya ini ada Hadijah.
Right.
She's from Turkey, live in Turkey. You
Yeah.
can say hello to audience.
Hello, everyone. Thank you for joining to our today's event. I hope
Yeah.
this session will be very informative for you. If you have any questions, you can put in chat section. So when I will finish at least one first part for section, we'll try to answer to them. And our today's topic is the grade control operations in NETPROMine. It's our huge update in new version. Currently, this version is at alpha testing stage, and we are still developing new features, especially in geostatistical analysis. So once we will complete and get better results, I will be happy to conduct the second session as well. So let me first.
And then in your team, Mr.
Yeah, should you
Serkan
translate?
and Elif, right?
Yeah, Sarkan, Ali, and Elif are from our team. So
Yeah.
Ali is our developer, Sarkan is our tester, Elif is our procurement manager. So
Yeah.
they also
Maybe
joined today.
they can open the cam. Maybe we can see.
If they don't shy, of course. As far as I see, Ali don't have a camera.
Hello, sir.
Sarkan and
Hi.
Elif.
Yeah. And then
Our company's heroes. So
Elif, right?
yeah, and
Yeah.
main hero Ali, but I see he has no camera.
Okay, okay.
So uh, let me share the screen first.
Ya, oke. Maybe tanpa panjang lebar ya teman-teman sahabat NETPROMine, kita akan mulai webinar kali ini. Oke, Khadijah time is yours.
Okay. So this is the new updated version 7.5. You probably have 7.1, 7.001, etc. But still in welcoming screen, we have the same familiar tabs where you can create projects, where you can see the sample projects, where you can write to support and download our manuals. And here our recent projects. So for today's topic, I created one Metallic project. I will show you the features into the same projects, in two files in order to save time. So let's get started. Before we go into the technical details, I would like to briefly explain why grade control is so important in mining operations. So when we are doing the proper grade control, we can correctly separate ore and waste, reduce dilution, improve recovery, protect plant feed quality, and of course, increase the profitability of mining operations. So Arizal, if you need to translate, please stop me. For that project, you may know this project from our previous webinars. It's a Chrome project, metallic project, where we made resource estimation, and grid control is for this project is one of the most critical steps between resource estimation and daily production. So let's assume that we have already designed our pit model. Let me show you. So we're at the stage to get these blocks for further operations. So I actually filtered this operation. So you may know how to filter the block model or block model based on the Z elevation. So I choose the elevation 446, 451 for that. And in order to make more simple and not complicated data, I decided to separate this block into 3 sections. So if we, let me show you. If we look at through this project, the open pit design, we can start, of course, our blasting operations from this step, from this part. It depends on how you create your road design and mining, and what is your initial plant design. But in order to simplify this situation, I just decided to make 3 sections concentrated on our ore blocks. So when we're preparing it, we need to find first how blasting will support our grade control operations. And for that occasion, let's focus on the first section. Let me, for a while, switch off. So here I define blasting area for this block, and also I filtrated in order to get more details about our block model according to my blasting area. So you can see more reasonable legend distribution of my grades. And we can observe that from there, that minimum point is 6.44 and maximum 70.04. If we get the report results, okay, let's assume it's 1. It's not important at that stage. We can see that our average grade is 1161 for this specified block model. So we can somehow make a conclusion that we can expect from this blasting area average grade as 1161. But let's see what we'll get after blasting and after drilling and the laboratory results. So to do the separation, if you're already a user of NETPROMine, you are familiar with this pattern blasting design. And we are here generating different patterns of blast design. So if we adding the blast design, we can see the familiar sections where we can see the mandatory rows which needed to fill in order to save the this sample. So let's assume that our blasting name is 1. Here's a machine drilling list where you can choose, and they will define your blast hole diameter automatically. If you don't have your specific machine drilling equipment specification here, you can write it manually. It's not restricted from the software. And you also need to define your explosive material. It's, for example, upfront. If you wanted to assign a description which will shown in your final report, you can add the description or you can assign to your teammates. Here, you can additionally add the diameter of explosives, and you can add the surface information, but what's mandatory here is bench length. So in this occasion, my bench length is 11 meters based on my open pit design. And here you can choose the pattern in which you can order your blasting holes. So square pattern is okay. So the second step is to fill here mandatory fields. Actually, if we go through all these parameters, we can see that it's a burden, the horizontal distance from a blast hole to the nearest pre-phase. So it's control how easily the rock breaks toward the open area. And spacing, again, the distance, but in this case, between adjacent blast holes in the same row, it determines how usually uniformly the rock mass is fragmented. Also, your blasting direction matters in this case. Sub-drilling is additional drilling length below the plant bench and floor. It can guarantee your breakage at the bottom of the bench. And blast hole length is the total drill length of the hole, including bench height and sub-drilling, and etc. So after making your first blast operation, you can see the automatically metrics here calculations. What we need to do here is fill them manually or calculate them automatically. For this occasion, we have different calculation methods, but I always relate to Anderson. And for this project, I defining the drilling angle values, parameters. So it will be 70. As a drilling angle, as azimuth, it will be 2 and 25. If we choose, for example, Anderson, you can automatically calculate and see your parameters. Even your automatic calculation give you the parameters. Despite this calculation, you can make adjustments in parameters, increase or decrease. For now, I will left it as the way it is. So that's for now, it's okay. We defined our parameters and it's saved in W1 in this case in the list. And the second step, what you need to do is to draw area. If you remember from the previous versions, we drew the areas based on the bench and projected them into all lengths to the final surface. But now you can freely draw any CAD object area and assign them as a blasting area. For this project, I prepared this area, and also in order to make it more valid, I generated the limit. So it will prevent you it will restrict your blasting operations for some, for example, relief occasions. In this case, it wasn't necessary to restrict too much, and that's why my blasting line is aligns with the border of my blasting area. And the second, at the second step, you need to take into consideration the direction of which you drew this area. And also, your area should be aligned with the surface which assigned to your block model. In this case, it's a bottom surface. For the further operations, we will not need them too much, maybe to see visually only. And while you seeing here blast holes, there is nothing for now because we haven't already started the blast hole. As you notice that there is an additional column where you can see your attribute. In this case, our attribute is Chrome 203. And we will fill them step by step. So let's define our blasting. We need to select the surface, blast surface. And here we have the guidance how to make our operation smoothly. If you will follow this guide, you will not be mistaken in your steps. So I'm choosing the upper surface and the blast line. And I need to choose the direction. So my drawing was in that direction. So I started from here and I'm choosing this part because I start from here to that direction and I can see my blast holes. So I specifically haven't changed anything in Anderson method. So it allowed me to generate 564. Yeah, 564 blast holes. And you can, of course, make, for example, let me show you the example. Again, 11. Again, choose the Anderson, choose your drilling angle. I'm using the same parameters in order to see difference more clearly. So automatically calculate and at any time change, for example, your spacing and burden parameters, for example, for 5 meters to 6 meters and save it. By using the same your patterns, you can see other design of your pattern of your blasting holes. So also from the previous version, you know, we can give the timing. I will not stop on the timing part too much. I just would like to show. So I have an example here. You can animate your timing. Let me switch off the labels and switch off the So based on your given parameters, it can show you, animate you which blasting holes will be blasted first. So after all, for this occasion, we generated our W1. And we can see here how blasting holes list have been filled. So I haven't give a delay for this blasting hole because it will take time to get report and match them. And it's a time-saving operation. And here, I still don't have my values because I drilled, I sent to the laboratory, and I'm waiting for the geochemical analysis. So let's assume that we already have that. And let me show you the minimum requirements for this kind of reports. And report 3 is a better example for this project. So As usual, it's a blasting number. It's the length of your blast. It's a drilling angle. It's azimuth, sub-drilling, delay, absolute delay, X, Y, Z, stemming, and etc. So here I have the value actually of my attribute. If I will go to the further lines, I will see my values. So I rounded them. Actually, it's rounded automatically. Let me fix it. So here's our values. So next we are doing the report evaluation. So we are importing the report to our blasting area, and then we smoothly go to the grade control operation. To do so, again, we're choosing our blasting sample, and here we are clicking on read blasting. So I'm choosing my report 3. If you have already imported the dataset to NETPROMine, this is the standard list of importing. Here in transfer type, we have blasting. It's a new feature. And based on your delimitation, you can here adjust your delimitation process. And what we have here is a file column. It's a column to be matched. Column to be matched, it's a minimum requirement for the blasting operations. So here we can see that azimuths from the file and the column to be required are matching. XYZ coordinates is also stemming. We have the column charge, the blasting hole number, length of blast, drilling angle, sub-drilling. No, we don't have sub-drilling, and it's a mismatch. We don't have delay, absolute delay, and we have bottom charge. Let me find it. And we have our attribute value. So regarding the attribute value, I'll be more precise a bit further. So based on what we have, we are just applying. And our last sample is updated. So actually, you can do from the one project the same to get report, to get analysis and input them. But it's also recommended to make them in separate templates. Why? Because you need to maybe check your blasting analysis and see your reports in different templates. So as a before and after. So before and after I have as a B1 and B1/1. So both are acceptable, both methods are acceptable, but for comparison, I also recommending you to create additional template and choose the same parameters, but in this case, read the report. Okay, let's go again from the V, and in this case, in blast holes, we will see that our geochemical parameters have been imported. So there is an error. I fixed it. Maybe I forgot to save. That's okay. If it will hurt us too much, so I will fix it again. Now we can see our blasting drill holes aligned with our bottom surface. So you can, for example, later choose the blasting line as a baseline and continue to create your mine design, your bench from this line as well. It totally depends on the situation, how you geotechnically wanted to proceed. And in this case, as far as our topic is not open pit mining, I will skip this part. But if you are interested, we can go, we can arrange the detailed training regarding these cases. And here we have tabs. It's a home tab where you can do your CAD operations, create new lines, areas, and stereometric figures. Modeling, and we had the implicit, we had the stratigraphic. In statistics, we have a new feature cupola. It's another topic of discussion, so I decided to arrange maybe the second webinar regarding the geostatistical analysis. So there's your preferences view and the window operations. So we have total new tab here. It's a grid control where you can create your model of the blasting area. NETPROMine allows the users generate a block model and a solid model simultaneously. You can add the composite here, and the composite in this case will not require you any additional statistical analysis. You will just input your grade control results. So for this occasion, I have completed some operations and I will show you the parameters. The same project, and but Blast Design, there are more. Okay, so our B4 is our latest template, the same. And here I need to create a model. In order to create a model, I need to give it a name, to choose my blasting. In this case, we are choosing our blasting with a grid control. Let me check again. Do we have here the samples? Yeah, we do. And I recommend you to work on composites in advance as well, but we will go through that as well. And in analysis, we are choosing our attribute value. So your attributes might be different. So there will be expanded list and you will choose your attribute. And for each attribute, you will see your grade control analysis separately. And if you need to make additional area for your blasting limits, you can add for each, you can widen your space. If you wanted to use your raw sample data, you can use, but it will require you additional composition part. I already made the geostatistical analysis, so we don't need in that project that. So here you are choosing the main block values of your blasting area.
Nggak kelihatan, Pak. I cannot see the screen. Sorry.
Maybe because of the connection.
Sudah terlihat?
Can I ask you a question, Hatice? Because it's
Yeah,
already 30 minutes, right? You say that in the first time you will be interactive because you are so many things that you tell that I cannot understand. Can I ask you a question? Just in brief, maybe just tell me about the new features in general, and then maybe just a couple of the screen that new features, because I cannot distinguish between the new features and also the present for the 7 the legacy machine.
Yeah, grid control operations are the new features. Let me show
You
you.
cannot see the screen. It is, yeah. Okay, thank you.
Udah terlihat sekarang, Pak Guzian?
is the same problem with other participants?
Okay. Yeah, got that.
Okay. Can you see now the screen?
Yes, go
Okay.
ahead.
Okay. So basically, now you can create your blasting patterns in NETPROMine in free mode, and based on your chemical analysis, you can make a grid control operations. So for that occasion, we have already done the creation of blasting patterns. So we have here 564 blast holes, and yeah, and you can see the results from the chemical analysis here. And to do so, also you need to draw in the right direction your limits. Let me show you again. So I drew in that direction from there. So my point of direction will be here. So if you will need additional training or consultation based on your database, you're welcome to write me. And also you can give the limit to your blast hole direction for geotechnical reasons, for example. And then when your limits are defined, when your boreholes are defined, you can go to create a model. So let me show you again the block part, which we're taking into consideration for that project. And for this geostatistical analysis, we have done the compositing. You're already familiar with this window, but here, if you've noticed, we have a grade control row, which is automatically comes from this tab. So if you go as usual from composite, add composite, it will not be activated. So you need to go from the grade control part. So let me first create a model name and define the parameters, and I will briefly introduce you a composite part as well. So let's call it D1. So my blasting pattern template before. And as analysis, I'm choosing my attribute. In this case, I'm not using the borehole raw sample data. I can be okay with these parameters, or you can divide it, for example, into two in order to get more small blocks and precise analysis. Again, depending on how you decide your excavation, how you wanted to get a report. My total bench height is 11 meters, so I wanted to have two blocks in each direction. So it will be totally fine to save in these parameters. So here, as we defined our parameters, the system says us to select the blast area. So do not forget to save your blast area if you are drawing in NETPROMine. And it automatically creates a block model and solid model. So let me switch off. So while I have the block model, the operations are continuing the same manner. So we need to add the composite. In this case, when we went through this tab to the composite, we can see our grid control list. And you can choose your grid control pattern and give the length, name, and choose the attribute. and start your statistical analysis. So here you always will have the basic statistical information based on your group, based on your data type, even if you're using the stratigraphic modeling. And let me show you one example. For example, in this Chrome, we have number of samples, minimum, mean, median, etc. You can export the statistics to your desktop. So this is a hint how to choose the parameters. So I've already choose the parameters. Yeah, the same. And no, I haven't chosen. Okay, let me choose. And before I'm choosing as a grade control the pattern because I've already exported, imported, sorry, from the desktop the analysis part. And let's assume it's a D1. You can use the core efficiency, you can make a constanta, you can change here data type, but in this case it's automatically shows your attributes, and other like features are the same. By clicking OK, you're saving here your composite analysis. So what else we can do? We can do, as usual, our geostatistical analysis from here. You can use your nearest neighbor, inverse distance, cupola is the new feature, and kriging. But for this like slide, we don't need a kriging or cupola, so inverse distance is fine, totally fine. So if I'm not mistaken, I already done. Yeah. Let me show you. So here in this part, also let me give it transparency. We encountered the blasting blocks for these or model parts. So we can see discrepancy here. We can see the deviation. So we need to decide, is this, for example, geostatistical analysis for this part, for these blocks, were done correctly, or if we have a skewness, to what extent? So in order to understand that, we basically need to divide our grade control block model to areas. So it's a basically mapping. It can come from the field, the coordinates of your, for example, limitations when you're after blasting, making the limits for your areas. You can send to NETPROMine initial and end coordinates and be more precise in your spacing. But in this case, I will draw. I have many examples here, so we'll see them. So in cross-section part, I am just creating new group in order to guarantee that my whole drawings will remain the same. As you can see from our legend, here we have from 0 to 4.5, and from 0 to 18, we have the values for this part of block. In order to be more correct in our like area mapping, we need to refer to the same legend interval as here. So it's 1.5, for example. So I'm quickly adding new numeric range. And giving the So let's assume it's 1.5. I'm clicking OK and prefer my own color range. So it's more or less understandable now what we have in which parts. So let me show you the scenario again. This is not the critical part of the bench. So in order to, for example, reach this area, you maybe needed to blast this area, and then reach this part. So even if you reach this part, we still can observe that there are blocks which have less value. So if you wanted to ignore in your grade control operation, if your, for example, grades are above the minimum grades, above this 1.5, we have a filtering operation. So I always recommend to make a filtering operation. I'm choosing my attributes from the list. I'm choosing the sign more than, for example, 1.5. And I always choose the central point of the block for filtering criteria, but you have the two other options as well. So when you apply the filter, you can see your more valuable blocks. So now the drawing operation will be more easier. So just in case I'm copying, so this is my final, and I'm removing this filter. Maybe we'll need this model further, that's why. And let's draw. Roughly, I recommend to, I see here the 3 areas. So the more you mixing the less valuable blocks with the more valuable blocks, the more you will get the dilution amount, the more you will have loss. And in order to avoid these occasions, we need to be precise in our drawings in this case. But again, when your coordinates from the field comes, it's more reliable. And here I am going to home section and draw the area. So let's W1. Here we have the snap point options. For this occasion, in order to choose the corners of the blocks, I'm choosing the last point. I'm starting my segmentation. My first area is ready. Let me show you. And in order to see it all time my project, I'm saving the section, cross-section part. So let's do the same operation for other parts. Mm. Maybe this part will be okay. So I should include maybe this part to the first area. I noticed it now. So let's go to the W2. It's easy when you using the right snap points in 3D. Maybe these blue ones I also will include. Yeah. The only concern is 3 blocks, they should be at the first area. This is our second area, and I'm doing the same operation. Two. Okay. And the third area. Oh, yeah, the wrong snap points. The more precise you're creating your areas, the more good results you can get from your birth control results. And I'm doing the same. So let's check to what extent our distribution changes if we change the thematics. So for 5, minimum 5, 13. Okay. Maybe 3. It's not necessary to do that. Yeah, it's changed a lot. So our first thematic is more correct. So now it's time to define your areas. Okay, our original blocks are here. So you can make area for your waste as well, if we consider the red blocks as a waste. So I did it, actually. We'll see the results a bit further. Yeah. In gate control, we are creating the areas. And we can choose our area, first area. Let me. Yeah. This actually should come to list here. No. Okay, create, update. Here we need to select our block model. Yeah, I haven't followed the message. So when we are doing different kind of templates in grid control, we are making a list where we're deleting the latest one. And here I'm choosing the highest quality for this. Let me see my legend. 10.5 average for this. They're overlapping because I snapped the borders. So that's okay if they're overlapping, but if they're crossing, they can be misconcepts. And let's 7.5 to 9. Yeah, we're overlapping and getting okay. Here we can see our sketches for our block model. Here we can get for the preview to our sketch and import this data. The area information, the average tenor, the volume, etc. And also you can go through the grade control report where you can see the different information regarding your area, to what extent, for example, you have missed blocks, dilution amount, and then decide your change your parameters if it's needed. So let's see the filtered block first. So we will have here the information about the legend, the area, the volume, the tonnage, and the block count. And here we have the average grade tenor information. It's a weighted average grade of the material class, typically weighted by block volume or tonnage. So in this case, we have missing blocks. The number of blocks within the mining area, blasting operations, that do not have valid grade data, and they need to be checked. And usually they occur due to insufficient drill hole coverage, even blocks stay outside the border, and also data quality filters. So the volume the same, we are just multiplying to density, and dilute block counts, the number of blocks affected by mining dilution. So when we're mixing low grade blocks with the highest grade, so we are increasing the dilution amount. Yeah. And there's also diluted block counts and volume and their tonnage. So here this summary report of all information. So you can export it in Excel and CSV extensions to your desktop, and also generate different kind of scenarios. Do you have any questions?
Ya, ada yang mau ditanyakan?
I will be happy
Oh ya,
to, yeah,
oh ya,
yeah, sorry.
terdengar ya, Pak? Terdengar ya, Pak ya?
Ya, terdengar Pak Guzian.
So, hey teacher, thank you for the explanations. So I think it's quite comprehensive. So I really I don't really understand actually. So just to in general, so what is the new feature that you just explained here? So there's no present in the present version in the 7.2 version.
Yeah,
So is all new or what
yeah, it's all
you
new.
explain? Yeah, okay.
We have in our NETPROMine the open pit mining operations. So
Okay.
you may know about them. And we had the blast design. Before we had the complications with the blast design, there were requirement to make, let me show you.
Yeah.
To create, we were allowed to create our blast design only by choosing the blocks. Now you freely can draw area and say, this is my blast limit. So there is no restriction anymore. So you can choose freely or import the coordinates from your tachymetry and start your blasting. Then we also added the importing of geochemical analysis to our blast holes in order to go to the grade control. When we're drilling based on our pattern, so let me show you. We are getting samples from each borehole, and these samples are usually went to the laboratories in order more detailed get information about the attribute value in short time in a specific local area. So it helps us to validate our main ore block model. So update, validate if we have mistakes, because when we get information from the laboratory for more specific area, there are chances that this is more correct part of estimation. So grade control allows you to model this updated part of your block model and validate your main or body and update if it's needed. Before in other versions, we hadn't grade control. It's a new feature, whole new features. Is it was clear?
Apakah sudah jelas, Pak Gozian?
Terus
Ya.
suaranya, oh ya oke. Ya udah ya jelas sih Pak, udah Pak begitu Pak. Maksudnya biar lu lebih detail lagi kan untuk nanti mungkin jelasan untuk fitur barunya gitu. Tadi
Betul.
kayaknya sih
Nanti kan
kecepatan
juga
mungkin teman-teman juga kayaknya mungkin kurang bisa memahami sih gitu. Kelihatannya karena kan tiba-tiba juga kita nggak.
iya. Khadijah, is this the F release to public?
They will be released in 2 weeks, maybe. Yeah, no more than 2 weeks, alpha version. So the customers during this alpha version can test it and also can suggest the improvements during this version.
Maybe 1 month again release to public, to customer, right?
Yeah.
Okay.
Okay. So if you have any requests regarding the testing, to demo licenses, to pilot projects, so feel free to request. We're in touch.
Ya. Jadi nantinya yang sudah menggunakan NETPROMine, kita akan sosialisasikan lagi kira-kira feature-feature mana yang terbaru dari yang versi 7.5 ini. yang udah pengguna, don't worry, pasti akan kita akan berikan dan sosialisasikan. Apakah ada yang mau bertanya lagi? Mungkin dari Ame ada yang
Yes,
mau
hello, can you
ditanya?
hear me? Hello, hello. Am I
Halo?
audible?
Yeah, I
Yes.
can hear you.
Yeah, so my name's Sima. I'm from AME. AME is like a consulting firm from Indonesia. So we are actually, no, not we. I mean, me, myself, actually new to this NetProMine software. We we usually use different types of software, but can I ask something outside of the new features?
Yes, sure.
Yes, so uh, I'm really looking forward to road design tools in mining softwares because, as we all know, maybe like the best software to use in road designing is probably either like Civil AutoCAD 3D or maybe like
Mm.
Bentley Open Road Designers. Now, I would like to know the capability of NetPromines itself on designing roads.
NetProMine itself can make basic road design itself, but for road construction operations, we have another software. We call it NetPro, which allows to design roads, tunnels, bridges, and calculate the volumes, make cross sections. If you're interested, I can make a separate meeting regarding NetPro and introduce you.
I see. So it's a different software, yeah?
Yeah, yeah. Initially, I will send you the brochure of the product so you can see. And if you're interested, I can show you the features and provide you demo license.
I see. I see. Okay, okay. Can I ask another question?
Yeah, sure.
Yes,
So
sure.
I see in one of your toolbars is stratigraphic modeling. Can you show it to me?
Yeah. Yeah, we have here the stratigraphic modeling
Borehole
toolbars.
calculation, false text definition, merge intervals, integral
You
surface.
can do here the correlation of boreholes. You're choosing the group or choosing from the screen.
Mm,
Then you're adding the intervals. So intervals we are defining here in the properties. So we have list of groups like seam, oxidation, so forth, giving the color. And you can edit, display, see the variation of lithology. In this project, we don't have variation. And also you can add the stack. So stack help you to save 2 or 3 seams or group of lithologies. You can merge them again and then divide, for example, your main seam model into small seams. If you need to demonstration regarding this, I can also may arrange. Here you can save unlimited template of your settings and then compare them. This is the main one, the model definitions. So let me first create the template. Here you can restrict your model, which will introduce it by the topography. You can give here some rules, like based on your data type, lithology or intervals, your interval type. And here we have the filtering operation based on your elevation throughout the borehole. and defining the relation, the continuity, and saving the settings in the particular template. Advanced settings helps you to give more precise restrictions, such as minimum ore thickness, waste thickness. You can, for example, give here some parameter and say that thicknesses which below this parameter, for example, 3, will be ignored during the modeling if it's needed. So you can, if you have pinch out, you can add the angle for searching automatically. You can give the restriction for your pinch outs and simplify your surface, make it more smooth. The standard grid, global trend, we also call it. So it will need to have more holes here. So you can add extra distances, because if we don't add extra distance, your produced model will be the limit of your borehole, which is not correct during the stratigraphic modeling. And you can create automatically surface, a solid model, or both of them. This is also very cool part of the NETPROMine. So if you wanted to explore more, we can arrange separate session.
Is this based on grid model or block model? I mean, like, if let's say we are working with a grid model, the main problem that I used to encounter with grid model is that I cannot use it as a base for pit optimizations because the geometry is not fixed. It's a grid, not a block model. So I need to convert it again to block model, and then I can optimize it. Now,
Eh,
what is NetProMine using? Is it a grid-based model or a triangulation and then block model as the resource model?
It gives you directly can give you directly the solid model, which is calculating in 3 methods. So you can give the restriction to your triangulation here to make more precise, or you can draw the area and define the area here in settings, so it will not go further through your limitations. So you can filter your boreholes to groups and make based on areas different type of methods, and then merge them. And yes, first you are creating at least a solid model, and then you are going to the block modeling operation.
I see. So NetProMine is calculating the resource based on block model, yes, not grid, yeah?
Yeah.
Okay, okay.
In implicit modeling, you can use the global trend and multi-quadratic methods, but it's in case if you have, for example, in one project, very distanced ore bodies. So it works very cool, and you can calculate the variogram and add your grade value here. Also, you can, in
I see.
grade part, you can add the restrictions to attribute. If you know that this block model will be generated for process, can give the value and use the raw sample or composite data. It's also important. You can add the process efficiency, the mineral price, the units, etc. In stratigraphy, it's very important to have precise rules, and there are a lot of additional editing tools in order to make your models more correct. Yeah. Also, it's not necessary all time to make your model based on your grid. You can also select the boundary and create your model based on the boundary as well.
No, can it work with a borehole that only has like, I don't know how to say it, like let's say a coal model, coal, we call it batubara here, a
Yeah,
coal.
yeah.
We only have like the roof, the floor, and the other interval is missing. So maybe like in a borehole with a total depth of like 50 meters, we only uh intersect with two seams, let's say seam A and seam B, where
Mhm.
the interburden and the overburden and the underburden interval are missing. Can we model that here? Or I see in your example that we need contact points like in other solvers, like contact point between A, B, and C, and then it will make a surface over. But can we make it without the contact point?
We do usually have, well, let me log into any project to show you. Okay, I already have a template. Here in rules, we can define the rule, the pinch, 0 point, and continuous. So when it comes to the, let's say we have 3 boreholes here, and okay, I need to change it. Okay, we have here the same. We have here the same seam, but when we are modeling, and sometimes we need to consider the neighboring borehole, and if their direction at the same goes to the this direction, we need to define will it be pinch out, will it be defined as 0 point or continuous. So continuous, it's basically ignores the adjacent boreholes and correlates in that way. When we are defining the 0 point, we are considering the half of the distance between two neighboring, 2 or 3, and space it can be more, and pinching out based on the half distance. So your modeling will stop there and cut automatically. So they will not intersect. Or they can pinch out based on this borehole, which is stands between these modeling procedures. So it can be lithology and lithology at the same elevation. So they are just pinching out based on the top. So they will not intersect if you will give the proper rule. Otherwise, yeah, if you will go based on the continuous rule, yeah, you will see this kind of problems. So that's why we have rules which our users need to try and see better results. Any other questions?
Yeah, I think that's all. Thank you.
If you'd
Yeah.
like to test, so I can provide you demo licenses and training, basic training.
Izin menambahkan Pak Sima, mungkin nanti after webinar ini kalau emang kami boleh mempresentkan di AME ya, boleh kita arrange kapan, apa online atau gimana. Paling gitu Pak Sima ya.
Iya, makasih Pak, makasih.
Siap. Mungkin ada lagi yang mau bertanya? Mungkin Pak Fadia atau Pak Rifan yang mau ditanyakan. Oh, Ibu Evi ya, dari Cerindo Mining Utama mau bertanya. Jadi setelah webinar ini mungkin apabila teman-teman atau sahabatnya permain yang ingin secara detail kami presentasikan bisa menghubungi kami di kontak yang ada di kolom chat atau nomor WA saya akan saya cantumkan. Sekedar mengingatkan, jangan lupa untuk isi absensi ya. Ya, kalau dia memberikan sertifikat webinar kali ini bisa mengisi form yang ada di kolom chat. Gitu. Mungkin ada yang mau ditanyakan lagi? Mungkin selanjutnya setelah pemaparan kita sesi foto bersama ya. Boleh di on cam sahabat NETPROMine. Mungkin operator lagi men-set agar bisa foto bareng. Oke, semua sudah on cam ya? Oke, satu, dua, tiga. Ya, sekali lagi. Satu, dua, tiga. Ya, terima kasih sahabat pemain. Setelah sesi foto bersama kita lalui dan kita masuk sesi akhir, eh, terima kasih atas atas waktunya untuk menghadiri webinar NETPROMine kali ini. Akhir kata, webinar kali ini saya tutup. Wassalamualaikum warahmatullahi wabarakatuh. Sampai ketemu di webinar
Waalaikumsalam
berikutnya.
warahmatullahi wabarakatuh.
Terima
Waalaikumsalam
kasih
warahmatullahi
semuanya.
Waalaikumsalam.
Terima kasih semuanya, Pak Aris, terima kasih, Harija.
Ya, terima kasih, Pak.
Terima
Ya,
Thank you
kasih,
for
terima
your
kasih.
time.
Thank you.
thank you Hariza, thank you Serkan, thank you Elif.
You're welcome. In touch.
They have they in here, still in here. Halo Khadijah.
Yeah, I'm here.
Okay, thank you for your time. It's good. Your presentation is good.
Thank you. Thank you for organization.
Yes.
It's cool.
Don't forget the price. Yeah,
Yeah, we will discuss it.
you can share to me.
Yeah, we will discuss it.
Okay, okay.
We are
Thank you,
now on the
Hadija.
recording. Yeah, see you.